We're using logarithms with our geometric progressions. One approach that we can use to solve exponential equations is to take a logarithm of both sides. Be careful to note that log A is negative if A is between 0 and 1. So you think of the log graph that starts the asymptote, like next to the asymptote way down low, it comes up through the 1, and then it gets bigger from there. We are going to solve these little inequalities here to find the smallest integer such that 4 to the power of n is equal to 500,000. Now, you could use trial and error. You could sit there in your calculator and go 4 to the power of 2, 5, 6, and see how long it takes for it to just go over the 500,000. Or we could use a sliding base. Okay, so we could leave our n over here and slide the base across to be log base 4 of 500,000. Now you don't have to worry about the inequality sign changing. As long as you just slide the base across, it's still fine. So type that into your calculators. What do you get? I think I heard it. Was that 9.5? Yep. Okay, so n, if this is a series, you can't have a 9.5 term. It has to be a whole number. So you're going to go to the next term and say, therefore, n will have to be equal to 10. N equals 10 would be the first one that is bigger than 500,000. Anything beyond that will obviously be bigger as well. Okay? Let's do that again. So we're going to keep the n over on the left, slide the base across to be log base 0.92 of 0.05, and then you can put that in your calculator. Life is so much easier for you guys with these new ones, isn't it? Don't even have to do a change of base. What do you get? 35.9, correct. So this time we're going to say n, the smallest value that it could be, would be 36, correct. Let's double check it. So if we type this in, we'll go 0.92 to the power of 35. It's actually bigger because when it's a decimal number, the power, that's bigger than 0.05 because 0.054. But if I go to 36, then it's smaller. It's tricking because of the decimals. Okay, question 2. The profits of the Extreme Sports Academy Company have been increasing by 15% every year since its formation, when its profits were $40,000 in the first year. During which year did the profit first exceed 1.1 million? What kind of series is this going to be? It's a well, kind of giving it away. We're doing GPs today. Yes, it's a GP. The first term is the 40,000. It says that was the profit in the first year. What is R? If you times by 0 point anything, the terms are getting smaller. 1.15. So increasing by 15% means you need the 1 plus the 15%. So it's 115 or 1.15 as a decimal. We are trying to find when the term exceeds 1.1 million. So let's put that into our formula. The formula for a GP is T of n equals AR to the n minus 1. I'm just going to solve this as an equal to, and we'll know that we need to go to the next one along. So it'll be 1,1,0,0,0,0 equals 40,000 times R, which is 1.15. And there's the power of n minus 1. That n is what we're trying to find. We're trying to find how many years it takes for it to get to the size that we want, or the amount that we want. So let's solve the equation. First thing to do? Not yet, can't do that while there's something in the way. The 40,000's in the way. Divide your 40,000 away first, and you get 27.5. Now you can do your sliding base. So n minus 1 equals log base 1.15 to the 27.5. Okay, typing it in. Actually, sorry, I'll leave that as an n minus 1 for now. Anyone get an answer? Yeah, 23.7, which means that n, when you add the 1 over, would be 24.7. So the first year that the profit is going to exceed 1.1 million is the 25th year. So we'd say, therefore, during the 25th year. All right, part B. During which year did its total profit since foundation first exceed 5 million? Total profit. What's changed here? That's now the sum. Good job. Wants all the profit over all the years to be 5 million. We still have A is 40,000, R is 1.15, but this time my sum is 5 million. Which sum formula am I going to use? S of n equals. There's two of them. Which one? Starts with an A. Then it has a bracket. Wrong choice. R first. Because R is bigger than 1. But a good try, Javon. At least you had a go. So it's R to the power of n minus 1 over R minus 1. Because R is greater than 1, so we want it first. Okay, subbing in, we get 40,000 times 1.15 to the power of n, which is what we're trying to find, minus 1. Now, please be careful how you write that, because if you write that little minus 1 so it looks like it's up here, it's completely different, okay? Also, the sum, I know that, the 5 million should be over on this side. I subtracted the 1 straight off the denominator. Make that a little bit nicer down there. Okay, so trying to get the n by itself, I have to move these things here away. So you're going to times the 0.15 over and then divide the 40,000. You can do it in 1 step or 2. That's up to you. I'll do it in 2 steps. So timesing the 0.15 over, you get 750,000. Okay, now divide your 40,000 and you get, anyone done it? Yeah. Okay, so I've switched my pronumeral over to the left side. So now I'm going to add the 1 over, so 1.15 to the power of n is equal to 19.75. And now we can do the sliding base. N equals log base 1.15, 19.75, and equals 21.34, which means during the 22nd year. Okay. Question 3. Sales from the warm and fuzzy calculators in the mountain town of Matsville, I think we've had this place before, are declining, oh no, by 6% every year. In 2016, there was 50,000 calculators were sold. During which year will the sales first fall below $20,000? We know it's a GP. We know our first term is $50,000. If the sales are falling by 6% every year, what is R? Percent, good, or 0.94 as a decimal? Well done. Is everyone okay with what we're doing with our rates? Yeah? Different to the last one that was increasing, so we added the 1 on to the 15%. This one we had to take it off because our terms are decreasing by 6%. And the term that we are after is 20,000. We want to know when our sales get to that point. The term formula, which you've all memorized, is that one. 20,000 equals A, which is 50,000, R, which is 0.94, to the power of n minus 1. Solve the equation, move all the stuff away and do the sliding base just like all the other ones, okay? So let's divide the 50,000. 0.4 equals 0.94 to the power of n minus 1. Now we're going to leave the n minus 1 here, slide the base over to be log base 0.94 of 0.4. What does it equal? 14.8, excellent. Then we add the 1 over, so it means we get 15.8, which means that it will be the 16th year. Is that good enough? Maybe not. Because it says in which year or during which year, and we were given 2016 here. Can we go backwards 16 years and work out where that is? Are we going to just subtract 16? What did you say, 2001? Sorry, not subtract. We're going forward in time. Adding time. Are we adding 16 years, I should say? What are we adding? We're adding 15 because 2016 counts. All right, so the sales will first fall below 20,000 in the year, and you're doing 2016. Our gut tells us to add 16, but you're really subtracting 1 off that because of the inclusiveness of 2016 and 2000, the end year, which will be 2031. Or you can count it up on your fingers. Okay. All right, that's it. Yep.